All right. So, when I mean explain it, I mean use your own words and your own understanding to explain and then present a counter argument for what I'm saying. So, let's look at the facts. We have a PCR test, reverse transcriptase quantitative polymerase chain. So, we're given a sample. It's usually NP, nasopharyngeal. This to collect genetic material. We have characteristics of COVID-19 virus detection. That is our goal. And it will be amplified until it is detected. All right. And there is no standard yet, as of yet, for how many times, how many cycle thresholds we should be using. Or what is the cycle threshold we need to determine reinfection. Because let's not forget, I'll get to it. All right. So, and I'll also send you the articles for which this data was recently created. A lot of it will be worldwide because America has really, and it's a shame, they de-incentivized research to improve true health. Instead, it's really the reinforcement of misinformation, and that's a different story. All right, that's disappointing. So, let's get back to the facts. This is the goal of our test. These are cycles. I'll use a simple graph. So, whether or not someone is infectious, this is this. And we're going to use cycle data. And I will send you the research. So, it has been found, a lot of studies in Italy actually, where the virus is really, their data is running rampant and you have a lot of people dying. They found that 10 to 15 is our CT that we want, cycle threshold, for whether or not someone is infectious. Now, that infection rate severely drops from 30 to 40. And in a lot of other countries, you have to disclose a CT threshold over 30. Or, yeah, just CT. Now, why is this important? Because a lot of human beings will shed the virus in their bodies for up to 3 to 6 months. It's called viral shedding. It's very common. We don't need the coronavirus epidemic to understand that. Now, we don't quite understand the virus. So this data, although we know it is fact and that there are variances in population, and whether or not these coexistent variances in people matter when it comes to how we approach these tests in specifics. So because of this, if an individual were to get a test, and let's say, once again, their CT isn't, you're not telling your patient what the CT is. You get a positive and you get a negative. That's it. Not the amount of times the virus had to be amplified to detect this. So they could have gotten coronavirus 3 months ago, and they're still experiencing viral shedding. They're no longer infectious because we know your infection 14 days. All right, these things are fact. If you just put the facts together and you think on your own, that means that if you're not disclosing the CT, how many people are you telling to quarantine aren't infectious anymore? And how does this manipulate the data that we're getting to treat people? Because if we were to narrow the CT, and let's say we want to find people in this threshold because they actually are infectious and they are causing harm, see how my questioning of the PCR led to a rate, you perceiving this as disinformation. Now imagine if I'm a doctor and I could lose my job for wanting to study this threshold instead of this one. And how it affects our patients, how we should narrow, how we should tell people to look into these things, that maybe the scientists were wrong. Unfortunately, that kind of thinking is not really incentivized, and it's sad because people here don't need to be wasting tests. People here could spread it very easily and die. So, now, if I were to look at this in relation to antibody testing, unfortunately, I cannot move my phone because there is a